Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem regarding displacement thickness, momentum thickness, and energy thickness. So last few lectures we have derived and we have also seen that how this displacement thickness, momentum, and energy thickness are formed and how to derive that. So based on that concept, let's derive a problem. Let's solve a problem here. So find the displacement thickness, momentum thickness, and energy thickness for the velocity distribution. So velocity distribution will be given in the boundary layer, which is given. This is the velocity distribution given in the boundary layer, where u is the velocity at a distance of y from the plate, and u equal to u at y equal to delta, where delta is the boundary layer thickness. Calculate delta star by theta. Okay. So that means what is telling same thing. Like suppose if you consider. This is the plate is there, and this is our height, or this is the boundary layer, and this is the distance delta. What is talking? Delta is the distance, and here actually at u you can see where the velocity of the distance is from the plate. This plate is situated, which is situated here, plate. So that is at the distance of this is y, and at this point u equal to capital U at a distance of delta. Okay, so that's what is given in the question, and we need to find out delta star by theta. So this need to be calculated. Okay, now what is the boundary layer velocity profile distribution given? That is u by capital U, y by delta. So first things we need to see delta star is the displacement thickness. This is momentum thickness, correct? So now what I'll do, so I'll start from the starting, like what is the displacement thickness? So displacement thickness, we know that displacement thickness, I'll write in the short, we know that delta star. So delta star form, what is the formula was there? That is 0 to delta, and this is 1 minus small u by capital U into dy. Just you put the value of here 0 to delta and bracket start 1 minus y by delta bracket close, this is dy. Now the value is given, a velocity profile given, that's why I kept the value here directly. So now if you solve this, like one integration of 1 dy this one to this one, so we'll get only y, integration of y minus integration of y by delta dy. So that will be y square by 2 delta, and this is 0 to delta. Now just put the value of delta in this y value. So what will get here? So now I can write this is delta star equal to, put the value of delta here, delta minus 0, that is delta, minus this is delta square by 2 delta. Now just solve this one, we can get it. So delta square, you can see delta square will be cancelled. So here only delta by 2. So delta minus delta by 2, nothing but delta by 2. This is one simple answer. What we got? Delta star we got. Next, what is the momentum thickness? Momentum thickness equal to, we know that momentum thickness theta. So theta equal to, we know the equation again, 0 to delta and small u by capital U and bracket start 1 minus this is u by capital U into dy. This was the equation for momentum thickness. See, this is for these are the equations we have already derived previously, and this is for theta equation, momentum thickness. And while coming to the energy thickness, just u square and u square will be added there. So now in this, what we'll do, we'll just substitute the value of u by u equal to y by delta. So now what we'll get here, after substituting the value, we'll get theta equal to 0 to delta, and this is y by delta, u by small u by capital U, y by delta, and bracket start, this is 1 minus y by delta bracket close, and here we can write this is dy. Now in this, what we can write again, integration 0 to delta, again just to multiply this one to inside, that means y by delta minus this will be y square by delta square bracket close into dy. Okay, now now we need to solve this one again. So after solving, okay, not after solving, we'll see how much will be there. Theta equal to, we can write y by delta into dy, integration of 0 to delta y. So delta will be constant here, y dy. So y dy integration of what? Y square by 2. So I can write y square by 2 delta bracket start minus, similarly here also y square dy. So that will be yq by 3. So yq by 3, here already delta square is there. So delta square bracket close, and this is 0 to delta. Okay, now what we'll get here, just to solve this one, like put the value of upper limit, lower limit. So delta square by 2 delta. So you can write this is delta square by 2 delta. So lower limit 0, so no need to put anything. So just you put the upper limit delta here, you will get delta square by 2 delta minus, again similarly this is delta q by 3 delta square. Now delta square, this will be cancelled, and here if you cancel this one, we'll get only delta by 3. So delta by 2. So what will get here, delta by 2 minus this is delta by 3. So we'll get delta by 6. This is one answer. Now previously how much we got? Previously we have got delta by 2, and this one we got delta by 6. Similarly, now see what is our requirement is there. Now what is the answer is here. So because the question is given to find out the delta star by theta. So delta star by theta is nothing but we already found delta star equal to delta by 2, and this is delta by 6. Now if you just solve this one, we'll get the value of 3. So you'll be cancelled and 6 by 2 will be there. So final answer is 3. This is one answer. Now one more answer we need to find out, that is energy thickness, because in the question it is given we need to find out 3 thickness is there. Similarly, the third one that is energy thickness. Energy thickness is delta double star. So delta double star, we know that the formula 0 to delta, and this is small u by capital U, and the bracket start 1 minus, I told you this is u square by capital U square bracket close. So this is, see, previously only u by u was there, small u by capital U. Now a square is there. Now similar method, we just will enter all, will put the value of u by u, velocity distribution y by delta. So integration 0 to delta, and u by u is already given, that is y by delta, and bracket start 1 minus, here also y square by delta square bracket close dy. Again you multiply inside this one, similarly 0 to delta will get, and here bracket start 1 by, this is sorry y by delta minus, this is yq by delta q bracket close and into dy. So again we'll start this integration of this 1 by 1 term. This is y by delta dy. So y square by 2. So we can write this is y square by 2 delta bracket close. One integration completed. Next integration is integration of yq by del q dy, 0 to delta. So yq dy minus yq dy integration, that is y to the power 4. So y to the power 4 divided by, obviously 4 will be there, 4 delta q bracket close. Here upper lower limit, upper limit is 0 to delta. Now what we'll do here, finally just I'll write here delta double star equal to, what I can write, just put the value of upper limit and lower limit. Upper limit is delta, so we can keep the value of delta square by 2 delta. Lower limit is 0, so no need, minus again delta to the power 4, delta to the power 4, and this is 4 delta q. So we can see it will be cancelled, only delta by 4 will be there. So now what we are getting, this is also cancelled, so we'll get here delta by 2 minus, this is delta by 4. So if you solve this one, you can write 2 delta minus delta by this is 4, or we can write this is delta by 4. This is the final answer for this. Okay, this is about the energy thickness, this is about the momentum thickness, and this is about the displacement thickness. That means this much displacement need to be done for the displacement thickness to compensate its flow rate. To compensate its flow rate, we need to move how much distance? Now delta by 2. So how much delta is equal to what? Delta equal to the boundary layer thickness. How much delta is there? Divided by 2. So that much distance need to be displaced. Similarly, here also delta by 6 is delta total distance divided by 6. So that much distance need to be displaced of the plate. What the plate is there, this need to be displaced. How much value will be there based on that. Similarly, this also same energy thickness. So I hope you understand this problem based on the theory only. If you understand the theory, the problem you can solve easily. If you're still having doubt anything, you can give a comment on the comment box. Thank you.